Okay, let's dive right into this explainer. Have you ever wondered what it would actually look like if the Earth had its own nervous system? Not a biological one, but a fully digital one. Well, today we're exploring some absolutely groundbreaking source material on the digitally empowered circular economy. We're going to visualize how complex Industry 4.0 technologies are doing exactly that. They're acting like this glowing planetary nervous system specifically designed to save our most precious resources. It is a fascinating look at how completely invisible data is solving very real, very physical problems. So to really understand this, let's look at a real-world pioneer. How exactly is France rewiring the planet? Well, imagine zooming in specifically on the cities of Grenoble and Lille. You would literally see their physical infrastructure coming to life. We're talking glowing networks of energy and water pulsating right under the streets, completely upgraded from blind static pipes and wires into a highly responsive digital web. And getting that old physical infrastructure to kind of wake up takes serious commitment. 40 million euros to be exact. That is the massive investment behind France's GreenLys smart grid project. Launched back in 2011, this initiative was designed to rigorously test decentralized efficiency in the energy sector. Because instead of just blindly pumping electricity out from a central power plant and basically just hoping for the best, this investment aimed to create a grid that actually listens and responds. Now, the GreenLys project wasn't just some isolated lab experiment. It connected over 1,000 residential customers, along with 40 commercial companies right in the heart of Grenoble and Lyon. By networking all these users together, the system could optimize energy supply and demand in absolute real time. It's just a fundamental shift, right? Moving from a one-way street of energy consumption to this dynamic, two-way conversation between the grid itself and the people using it. Let's pivot over to Lille and see how this builds out into a totally different sector, water. Here, we have the Vig'ileo project, which is a massive partnership between Veolia and IBM. This system manages an astonishing 43,000 kilometers of water pipes. To put that into perspective, that is a glowing water network longer than the entire circumference of the Earth. And because it's so smart, it can instantly identify leaks, pinpoint pollution, and respond to sudden peaks in consumption, all in real time. Section 1, the invisible engine. It all starts with a foundational concept you're probably familiar with, the Internet of Things, or IoT. These are the connected devices and sensors that empower intelligent assets, basically linking the physical, digital, and even biological realms. So the absolute crucial point here is that IoT provides the raw connectivity and those dynamic feedback loops needed to gather all this vital, real-time data directly from the field. Without these little sensors, the grid is completely deaf and blind. Think about the exact type of sensor wheel used in these intelligent networks. We've got sensors for acceleration, temperature, humidity, and crucially, for our Lille example, leaks, levels, and flow. This is exactly the kind of technology Veolia uses to detect a burst pipe somewhere in their massive 43,000-kilometer network before a single precious drop of water is wasted. It is literally sensory input for a digital nervous system. But sensing is really only half the battle. You also need to think. And that brings us to cyber-physical systems, or CPS. These take those IoT devices and integrate heavy computation and networking. They link physical spaces directly to digital services for data-informed decision-making. Essentially, these systems take that raw sensor data, process it, and literally turn ordinary, dumb physical infrastructure into highly intelligent, self-monitoring assets. Let's quickly compare the old way of doing things with this new reality. Traditional grids, they are strictly reactive. They're wasteful, and they suffer from high technical downtime, simply because you only know something is broken after it actually breaks. On the flip side, smart grids, which are powered by IoT and CPS, are incredibly predictive. They're highly efficient, using real-time optimization. It drastically reduces energy consumption and cuts way down on that incredibly expensive technical downtime. Section 2, connecting the physical world. Zooming out a bit, Earth observation technologies use this exact same framework of big data, analytics, and artificial intelligence to monitor our oceans and lands. The numbers here are wild. This tech is saving 25 million euros annually just on oil spill detection monitoring. And in the maritime sector, optimized ocean current modeling is saving up to 8% on vessel fuel costs. It's the exact same principle as a smart water pipe, just scaled up and applied to the entire globe. Section 3, building a circular economy. The momentum behind all of this is simply undeniable. By transitioning to these smart systems, we drastically reduce waste, emissions, and pollution. We shift completely away from fixing things that are broken to predictive and preventative maintenance. We optimize resource allocation, enhance the lifecycle management of products, and enable entirely new smart product service systems. Ultimately, these technologies significantly enrich data-informed decision-making, which closes the loop on material flows and lowers the actual cost to our planet. I really want to highlight this specific quote from the source text. Combining them and repurposing data can promote competitiveness, circularity, innovation, and impact. Because the crucial point here is that this isn't just a feel-good environmental initiative, it is a massive economic advantage. Merging public, open data with private sector innovation forges a completely sustainable, competitive edge for everyone involved. It's honestly a thrilling sci-fi reality happening right now, mostly invisible, right beneath our feet and up in orbit. Which leaves us with a final, pretty provocative thought. If France can turn its water pipes and power lines into a digitally empowered circular economy, saving millions of euros and countless natural resources, how could your own city's grid be upgraded next? When will your hometown join this planetary nervous system? Thanks for joining me on this explainer. I hope to spark your curiosity to look just a little closer at the invisible digital engines running our world.